Welcome to MyProjectBazaar.com. Now we are going to discuss about the product deep learning for quantification of epicardial and thoracic adipose tissue from non-contrast CT. Now we are going to discuss about the abstract for the process. Hence, the increased epicardial-adipose tissue, that is the EAT, is associated with the presence and severity of the subclinical diseases. This process investigates the long-term clinical outcome of subjects with and without increase in EAT. Hence, this process includes the segmentation of the EAT regions and then classifying the EAT. Hence, the CTA diagnosis coronary-artery-disease, that is the CAD, was defined as obstructive luminal-stenosis is greater than or equal to 50%, non-obstructive luminal-stenosis is 1 to 49%, and zero obstructions. Hence, the major adverse cardiac event, that is the MACE, was defined as then myocardial-infarctions or the cardiovascular-death. Hence, this process is well applicable to segment the EAT regions and to extract the exact affected regions from the other associated parts. After the extraction of the exact regions, we can justify the process is efficient by estimating the efficiency parameters. Now we are going to discuss about the flow diagram for the process. In this flow diagram, at first the step 1 is the input image. The input image is taken from the dataset. The dataset is the folder which consists of the several images. After getting any one image from the input dataset, the selected image will be undergone for the pre-processing step. In this pre-processing module, we have two steps. First one is the noise filtering, then the second one is the image resize. The noise filtering is used to remove the noise present in the image. If the image consists of the sum of the noises, means the filtering will be removed the noise. After the noise filtering, the resize will be carried out. In this resize step, the image will be reconstructed into an aspect ratio which we have given. After the image resize, the segmentation will be carried out by means of the k-means clustering method. Hence, in this segmentation region, the affected regions, then the EAT regions will be separated by means of k-means segmentation method. After the segmentation part, the CNN segmentation will be also applied to extract the exact regions. Hence, in this CNN, we have three steps. First one is the thresholding, then the morphological, then final one is the pooling. Hence, in this thresholding part, the threshold limit will be applied. Hence, after the threshold applied, the morphological part is applied to remove the additional unwanted regions, and then the pooling layer is assigned to get the exact optimized result. After the segmentation part, the performance will be evaluated by means of the accuracy, sensitivity and specificity. By these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015B, then change the current directory. Now you can see the mainfile.m. If you want to execute the code, means just right click in the mainfile.m and select the option run. Now you can see the my dataset folder. Now open the dataset. After opening the dataset, select any one image from the dataset. After the selection of the image from the dataset, the process will be done automatically. Now the process will be shown one by one. Now the process was executed completely. Now I will explain the results one by one. Now this is the figure 1, which shows the input image which I have taken from the dataset. After the selection of the input image from the dataset, the resize, that is the pre-processing, will be carried out. In this pre-processing, first step is the image resize. Now the resized image is shown in the figure 2 with the title resized image. Hence the resized image will be in the aspect ratio. After the resize, the noise filtering will be carried out. Hence the filtered image is shown in the figure 3 with the title resized image. Hence in the filtering process, the noise free image will be there. After the noise filtering, the initial K-means clustering will be applied, and then the labeled image is shown here. Labeled image is nothing but the pixels will be the index 2, 1 and 3. Like this, the pixels will be clustered and then labeled. After the labeling, the corresponding labeled image pixels will be segregated. Now we have the 3 labels. So here the 3 kinds of images will be obtained. After the clustering, the final segmentation results will be shown like this in the figure 6. Now the segmented regions will be separated by means of the color segmentations. Then finally the final segmentation of the grayscale will be shown like this. After that, the pixels values based on the iteration is based in the best score value will be shown in the figure 8. After that, the segmentation, the feature extraction will be carried out. Hence in this feature extraction, the feature extracted value is shown in the table in the figure 9. After that, the classification will be done by means of the CNN classification method. Hence the results of the CNN classification will be shown like this in the message box. After the classification, the performance will be estimated and then plotted as a graph format as well as the table format. Hence the existing versus the proposed method will be calculated and then the evaluated, then plotted as a graph format, as well as the corresponding values will be shown in the table format like this. Now the volume of the EAT, then the time taken to execute, as well as the correlation coefficient value will be shown in this message boxes. At last, the mean square error value is shown here. The final time estimated graph, then the performance graph will be shown like this in the bar chart format.